Great. Welcome everyone to the third installment of our functional programming in Scala course online. Thank you for attending it. As Just to confirm, the recordings of these will be made available. I will announce it to the Meetup group and the Lumo with links as soon as I've uploaded them, and I've put in the chat links for the YouTube channel and the PeerTube channel that I use. Also, for anyone based in San Francisco, our next event is on this coming Tuesday in person. It is an in-person event, and we got two great talks. One, we got a speaker first from Netflix, who's done a talk at our meetup before, doing a talk, and the title of his talk is "Designing the Library Pairing Netflix's QoE with Scala 3." And also, we have a second speaker. Let's teach LLMs to write great Scala. That's on Tuesday in San Francisco downtown at 2BTV's office. Um, that's it for me. Over to our favorite Scala trainer, who tell us all about part three, and I'm hoping that he'll mention the word monads at least two times. Yeah.
I will. Hello, Sarah, and thank you. So yeah, if you probably know me already, but if you are the first time on this third of three lectures, my name is Maciej Gorywoda. I'm a project marketing manager at JetBrains, and I connect to you from Berlin. So a good morning and good evening slash get good evening from Berlin to everyone. Yes, let me just share my screen, and I will talk about monads today. Um, da, da, da and the screen and my first slide and already that word on the screen. So yeah, on the first lecture, because that will be more important than the second today, on the first lecture we talked that first of all functions in Scala and other functional programming languages can be used as first-class citizens. That is, we can just have them as fields in our class instances. We can pass them as parameters. We can return them from other functions as return values, and that will be important today as well. But also what will be important is that we talked before about Scala collections and about different transformations of collections, which not the most important maybe, but one of the probably the most the important methods on Scala collections is a flat map that allows us to take the contents of a collection, transform it somehow, and like create a new collection of the same type, but with something different inside. Not exactly one-to-one. Mapping would be to take one element and just mapping and to map it into another one element. Flat map lets us take the whole thing, the whole contents that we have and create some other contents based on that. And those two things will be important for today's lecture, because a monad basically is like a collection has one element inside, like monos in Greek is one, and it means simply that if we think about, I don't know, a list or an asset, a map, and so on, we usually think about collection having some many elements, possibly infinitely many or as many as we need. But in case of a monad, we are able to have some additional control over that collection, because there's only either one element in it or none. Although maybe I'm oversimplifying a bit, that's why we probably need to start with some theory and then go to examples, and hopefully everything will become clear. So first of all, a monad in Scala is just a concept. There's no such thing as a class called monad or trait or any other syntax element, although we have something called for yield syntax that helps us with monads, but also with collections. So that's not really monad specific. Instead, we can say that a monad is anything in Scala that fulfills certain requirements. And that is that a monad needs to have a constructor. So nothing really complicated here. Like every class which has some data in it has a constructor. That constructor in like a functional programming terms, not only specific to Scala, is called a unit method. It means that we have some content. We put it in as a parameter to a constructor, and we have a monad with that data inside. That unit method needs to fulfill the identity laws. I will come back to what identity laws are. It's nothing really special as well. Then, yeah, because we have that unit method, we need some value, some data that is wrapped inside a monad. But it will be one value, but that one value can be already a collection, right? There is nothing stopping us from having a list inside a monad, and then that list may have as many elements by itself as we need. And then we need a method that's called bind in some languages and flatmap in Scala and some other languages as well. And that flatmap method changes operations. So like we have a monad with some data inside. We want to make some operation transforming that data inside. And flatmap is our way to make it in one step, then make another operation on those transformed data in another step, and so on. So it's like having data inside a container. Flatmap lets us take that data out, transform it, put it back in the container. That container is still there, and we are sure about certain laws that control the container. The container has certain methods that we can apply, and it doesn't matter exactly what is inside the container. So like we have those two levels. We have some data and we have methods that can work on those data. And we have the container, the monad, and we have some methods that works on the container. And yeah, that map method also needs to fulfill the associativity law. I will come back to it in a moment as well, which means that in Scala, at least, there is really no way for the compiler to exactly like force us to have that this must be a monad. So this is different on a different level, more abstract, more mathematical, let's say, that when we have a trait that has some abstract methods and we just need to implement those abstract methods and we are done. Here it's more fuzzy. Here just if we want to have a monad, we need to remember that certain things have to be done in a certain way, but the compiler will not stop us from doing them differently. And yeah, sorry for that little joke. Generally, this is I tried to put the theory behind the monad as concisely as I can, and in the end, I decided that it's easier to talk about specific examples, and having those examples probably will be easier to explain the monad instead of just talking completely theoretically. So yeah, you have to see it for yourself. The simplest useful monads that are there are those three: option, either, and try. And all three of them are really in Scala very useful for handling errors. If we go now to, let's just switch to the IntelliJ IDEA. So as you may remember before, I talked about that example of having a database of users. And yeah, we have 11 users, they have some IDs, they have names, emails, and their age. And there is a map that maps a child to a parent. So a user with ID 1 is a parent with ID 3, and so on and so on. And so we can write a method, for example, that will, for a given user, give us also the user, like the entity of the instance of user data. That will be the parent of that person the original user. But of course, as it is in reality, we can't have a database of all the parents. Every person who is a parent has their own parent, and that person will have their own parents. At some point, our database will just end. But we know that even those people that was very, very long time ago, they also had parents. We just don't know about them. So here, for example, we have parents only for 2, 6, 7, 8 people, and not for some of them, like the number 9, for example. James Thomas, he doesn't have a parent in our map. Also, there is a possibility, like in this case, that we have some kind of error in our database. So Emily Johnson has a parent with ID 12, but there is no such user data in our database. And so we want to implement a method that would do that would get that parent. We need to be aware of a possibility that it won't work for every possible user. But anyway, let's try to do this. We need to go to here, option either try. And the way to do it, the way we do it normally, like in Java or in Scala, but in an imperative way, is to use exceptions. We can. I already wrote something here in Java called user service. User service has a method called find user. So I give a name to that user. The Java code takes the database, looks through the users, and return a user with a given name. So we can reuse it to find the parent of a given user that is identified first by the name. So let's go. Not here, here. So as first of all, we call user service find user for a name. Like we already have that parent for a name. So yes. Then we take the parent ID of that user that we found in the database. And for that parent ID, we again use the database to find a person that has that ID, and we are done. It's all fun. We can test it now. We have the main method here, not with either son. We will come to this, but with exceptions. Find parent. Yeah, and what we want is print line that parent name. So I made myself a few. Let's go back here. Okay, that should work. So yeah, for John Doe, for example, if I now run it and it asks me for the name, if I write John Doe, that will give me the right person, Michael Brown. I can go back to user data here. So that John Doe is user with number 1 ID, and the parent is user with number 3 ID. So Michael Brown, great. Let's try again. And this time, let's go for Emily Johnson, who has, yeah, so then there is no such user with ID 12. So what we got instead is a no such element exception. And yeah, here database find. Find would give us like a none, so no, not found the user data, but we also This method is quite simple, so we just call get on that result, being sure that we should be able to find it, which throws an exception. Similarly, in a bit different way, if I now go here and, for example, write my own name, I'm not in the database at all. So Maciej, that will give me another but different exception, illegal argument, no user with name Maciej. So yeah. And and also Jane Smith should be a different error. Yeah. Yes, even different error invalid. Jane Smith is in the database. Jane Smith is user data with ID 2, but such person is not in the map of parent. So we have three errors that can happen to us if we just use this simplest possible possible implementation of the method find parent. And what can be done, maybe not better, what can be more functional, is to use one of those simple monads, option, either, or try, to add that. And so we will start with options. Option is a collection. It's like if you think about a list and that can have 0, 1, or many elements, option is a collection that can have maximally just one element or 0. The unit method, so the constructor, is option apply, or more specifically sum apply. Option has two subclasses. One subclass is sum, and it's a subclass that has an element inside. And the other option is none, which has no element inside. So every time we call a constructor on option, then actually the real instance that is created is an instance of the subclass sum. Option empty is another possibility, but it's usually used to signify that we don't have a valid result, or it is used as a placeholder. So, for example, let's start with something also from the first lecture. We have this method for division, x divided by y. If y is 0, then we throw an arithmetic exception. Otherwise, we actually perform the division. So instead of doing it like that, instead of having a method that sometimes works and sometimes throws an exception, we can have a method that returns an option of int. And if everything works, if y is different than 0, so the division is possible, we perform the operation x divided by y, and we wrap it in sum in that constructor of option. Otherwise, if y is 0, so division is not possible, we return none. So the version, the subclass of option that tells us that something's invalid. Somehow we weren't able to perform the operation. And the flat map method of option is simply like a typical flat map method for any collection. We just take the value if it is there. So if our option is actually sum, then we will take the value out of it. We will perform some operation, and and at the end of that operation, if it's successful, we create another option and put that value inside. Otherwise, if our new operation doesn't work, then we can instead return an empty, so none, and the result will then stay none. Flat map called none doesn't work, so that helps us like making this like a list of steps with operations, and if we get a valid result at the end, then that ensures that tells us that every step in every intermediate step was performed successfully. if we get none at the end of our list of chain of operations, it means that somewhere there, we don't know exactly where, somewhere there was an error. And at that point, we got none instead of a valid result. And so no further steps were performed. This is the moment where the whole chain stopped. Okay, let's stop here as well. And then let's write the same method that we had here, the find parent method, but using option instead of find parent, instead of exceptions, sorry. Okay, that will go like this. Instead of, we won't use user service from Java, but we will come back to it because this will be important for the try monad. Database. So on database, we call the method find to find the element that has the name we give it. And if we found it, find will return an option of A, in this case, because database is a sequence of user data. So that option will be an option of user data. If we found it, then another step would be to flat map that user data to parents get user ID. So, okay, AI assistant already decided that it will just do everything for me, but let's go step by step. Here we find a user with a given name. If we did, then we flat map it to such that we look for in the parents map for the ID of a user with a given ID. And if we do, if we found that ID, then again we flat map it. We have this parent ID now. And again, we call find on the database. And this time we look for another user with that ID being this parent ID. So what we get instead of user data now is an option of user data. We will have to, at the end, when we call the find parent, we will have to extract the data from the option. So yeah, let's do it with option. And what we can do is to use maps. And because already we know that option has only two subclasses, that is some and none, then we can, IntelliJ IDEA can do match exhaustive for us, already generate this code. And now, I will take this, put it here, parent, so this value here, let's rename it to parent. And if it is none, then we know that there is an error. We don't know what exactly, which one is the error. As we just talked, there were three possibilities: that the given name is not in the database, that the given name the person with a given name doesn't have a parent in the database, or that user with that given name has a parent ID, but the person with that parent ID is not in the database. So let's call it now. And again, John Smith. John Smith has this error because there's no John Smith, right? It should be John Doe. So yeah, but we already know that worked. Yes, from John Doe it works. And if I remember correctly, the other was Emily Johnson. Emily Johnson also returns an error. And also Jane Smith was the third. Yes. So as you can see, in all when I wrote that John Doe person who has a parent in the database, then the parent was returned correctly. In all other three possibilities, we got error, but that error is actually something that we control. It's not an exception that was thrown, but simply our message here, print line error. And this is done in a, I think, quite readable way by calling a method on database and then flat mapping the result of that method, which is an option, into another option and another option, and in the end, just making a pattern matching to see the result. And that would be great, although we don't know what's the error, right? We have three possibilities. What are the errors? And we still, but all we can say is that somehow it didn't work. We don't know how. So that's something that with what has us another simple monad, which is called IDEA. And IDEA is probably the most flexible of those three, and also the most flexible of many others, because usually like the main way you use IDEA is like here for handling errors, but it can be used for many other things, and you can find it in code bases in Scala, performing quite a lot of heavy duty. So yeah, option can tell us that there was a failure, but IDEA is like a bit of a more complex version of option, where we have that other data, instead of having a valid result, which for income because of convenience is called right on the right side of the IDEA. The left side of the IDEA is where we keep errors. So if we have a valid result of operation, we call a right, and this is our unit, this is our constructor. But if our operation fails, then instead of just saying, okay, error, then we have a possibility to specify what that error is. One simple way to use it is to simply use string on the left, and then every error is just a string, just a message about what happened. Another, also very often used, is to implement an enum with some cases where each case is is exactly the error that happened. So, for example, so for every partial function that would just like this division, which would work when we have two numbers and the second number is not zero, so x divided by y should give us some real number as well. Then we would have right of that result, and if y is zero and so division is not possible, then we would have left of division by zero error, for example. Yeah, so also just like in case of option, we were we used that subclass sum as our real constructor, creating some a monad with a value inside. Here in IDEA we use the right. So, but this is just like something that the Scala compiler decided for us. It could be left as well. It's only a matter of consensus in the compiler. So yeah, for example, we can have, let's say, three methods: make x, make y, make z. From make x takes some element of the type t, and it transforms that element t into an element of the type x, or it fails. And if it fails, then it instead it produces an error. So make x returns an either instance of either, that is either the valid x result or the error message. And if it happens so that we have the valid x as a result of the transformation, then we can give it to the make y method that takes x, produces y, or it can fail, and again it will create an error. And then the same, if y is created successfully, then we can give it to the makeZ method, and makeZ method transforms the Y element into a Z element, or it can fail, and it produces even like third error. And as you can see here on the right, it at every point, if we produce an error, this is where our chain of operations stop, and we are just left with that error. And if the operation is successful, then we go to the next step. So this is how it looks together. Make x of t, flat map make y. This is a shorthand that would be like y arrow make y of x arrow make y of x, and that would be that again would create us a result of the type y or an error, and then flat map, and the same here makes c. The result is either the valid outcome of the whole chain of operations or the first of the errors. So if we get an error, this time we know exactly at what point the error, what happened wrong at which point. So we can now go back here to our example, and we can write the same code as before, but this time with an either instead of an option. So that will be here. Exactly. The first line will be the same as in case of option. But now, because find gives us an option, and what we want is an either, we call a method toWrite, which transforms an option to an either, and on the left we will have an error in the form of a string. No user of that name is in the database. So this is the first step, so the first error as well. Then if we found the user with a given name, okay, let's say assistant wants to do the rest. Let's do it. If we found that user with a given name, then we flat map it, and we can in the second line we can look in the parents map for a parent of that person, and if that we find that parent ID, then we return it as a write, or otherwise we produce a different error, no parent found for a user with that name. And then, given that we already have that parent ID, that this is successful, we flat map it again, and this time we look in the database for a person, for a user data with ID being that parent ID. And if we find it, then we go again, we transform it to the right, either right. And if we don't find it, then we produce third error, no parent with ID, parent ID found in the database. And we can now rewrite our code here with either find parent, and let's just do this again. Again, we can use exhaustive matching because we know that either can be only either left or right. So on the left we will have an error, and just print line error. On the right we will have some valid parent and print line parent. And again, we can say, so if I now go with John Doe, it will give me the whole user data. I should, in fact, just write parent.name. That would be better. So, okay. John Doe, great. So Michael Brown is the father of John Doe. Now, if I write my own name, so I'm not in the database, no user Maciej is in the database. If I write there was Jane Smith, and Jane Smith is in the database, but no parent of Jane Smith is in the database. And the last possible error was that of Elizabeth Johnson, Emily Johnson. So, yep. Yes, and no parent with that ID that is specified here exists. So, right. So that's for either, and yeah, that gives us quite a specific information about what went wrong. We could also, just for the kicks, let's write enum error here, and that would be case no user, no parent with ID, case invalid parent ID. And now instead of if I go here with either, instead of either string, I can write either error. And now here on every, yes, no, let's just take it a bit higher so I can see it. Okay, so now error, no user name. Up. Here, no parent found for user, so that would mean error, no user name. And here, no parent with ID, so no parent with ID. No parent with ID. Invalid parent ID, maybe that's not interesting. And now, I can do even better than this, because if I write now, for example, Emily Johnson, then that will give us no parent with ID. But what I can do now is, let's see if no. Okay, IntelliJ IDEA isn't that that smart, but it can do no parent with ID. I can already write it like this. No parent. And same for the other three. Okay, now you get it. Good. So if now I write my own name, for example, no user Maciej. So we are in this branch. And if I write Jane Smith, no user Jane Smith, that's all right, but we can have that other one. No John Doe. No parents. That would be Jane Smith, exactly. Or maybe I made that mistake somewhere here. Yes, no user. No, there should be no parent. Yes. So as you can see, if we can combine the fact that either can have a very flexible syntax, very flexible data for carrying errors on the left. We can combine it with pattern matching, and that gives us a possibility to be very exact about what's exactly happening, as well as being very precise about like it can be very easy to write the whole logic for handling. Sorry for handling all those errors. But one more thing that is happening quite often when we, especially if we write code that not only consists of Scala, but we access Java libraries, is that we quite often need to call Java methods that are where it is possible that they will return an exception, while we need to catch it and we need to do something about it. That would mean that like if we wanted to try to use either for that, we'd have to or we could use, for example, either that has a throwable on the left, a throwable given to us by Java, and some kind of a result on the right. And this is and that result that error, that throwable is happening because Java libraries don't work with iders. It just throws exceptions, or maybe not that method will throw exception, but another method that is called from that Java library will throw exception, and so on, and so on. It happens so often that in Scala we have a special like a special simplified version of either. It's called try. And try is simply as if we have this try-catch block in a form of a monad. So we can have a unit method, a constructor that is the call to to that Java library method. And if the call is successful and it will not return an exception, then it will give us a success with some data inside. And if it is an exception, then that exception will be caught. And instead of success with data, we will have a failure with an exception. That exception will be held also as form of a data, as if it was an either with a left and error message on the left. Only this time we are able to, we hold an exception itself. So that, as you can see, is much more concise and still very much idiomatic to Scala. So the way we use it is very similar to either. We just call a try and then inside it we give as a parameter the call to a method that can throw an exception. If it is a success, we can flat map that result to another call to another method that can throw an exception, and so on, and so on, and so on. At every point, if an exception will be thrown from that method, we will get a failure, and at that point, our chain of operations will end, and what we will get is exactly that throwable, that exception, and we will know at which point of our chain of operations something went wrong. Otherwise, we will just get the successful result at the end. Try has also a few methods that help us in a similar way that a try catch finally block can work. First of all, there is a recover method. If we have a failure, and then we can decide that maybe that exception really is not that horrible. We just need to return some default value, and we are done. So recover can do that. But there's also recover for situations where only some subset of exceptions that are being caught are exactly that we think, okay, so this exception and this one, they are not bad enough to just stop the computations. We will just use some default values. Otherwise, if the exception is different than those that we explicitly noted here, then that exception is a real problem. So we keep having a failure instead of a success here. Yeah, so we can do now, I think I did, we can write one more time with try def find parent user data. And we will reuse this thing, user service find user, only that if I go to here, you can see that, yeah, this will throw an illegal argument exception, exactly what I want. Cool. So, oh, let's go back to here then. And so I will do it like this. I will use try user service find user of name. Try needs to be imported, and this will, the find parent here will return try as well. Then I flat map this user to another try. This will always return something. Although not. This will not return. This will also throw an exception in a situation when this ID doesn't exist. And here's a bit of like don't do it at home. We have a database find ID that is the parent ID, and we call get because we are like so sure that that parent ID should be there. But if it is not, then we wrap it in try. If it was a serious code, I wouldn't do it. I wouldn't just use get here. But let's do it just for the sake of using the try monad here. So now, if I instead of with either, I will use with try find parent name, and then I can again use the exhaustive match, and yeah, we have final exception point line exception get message, and in case of success, just point line parent name. And let's say John Doe works. And let's say for Maciej, no user with name Maciej. As you can see, this is simply the message taken from the exception. Okay, are there any questions at this point?
I don't see any in chat or on Twitch.
Okay, so let's continue. One more thing I wanted to talk about here is that, well, as you can see, this is so far pretty simple to read. For example, in case of option, we have one method that returns an option, then we flat map to another option, then we flat map to yet another option, and so on and so on and so on. This is maybe not so bad, but quite often in more serious code, what we get is something like this. So this is already a simplified version of a code coming from a database I worked on. This was a code that was supposed to handle a conversation of a few users in a sort of internet messenger. So we have some team ID, we get team members based on that team ID. For every member, we want to get their user data, so we know what to display on the screen, their names, their avatars, and so on. We want to also log information that those people are in the chat. We have something called priority levels, because some people have different flares, different colors, depending on who they are in the team. And then, depending on all those things together, we can either, I don't know, send a message to all of them or not. Some operations are not allowed for people who don't have a given level or something like that. So you can see that those informations coming from different call methods are like mixed together, and they are all needed to for logic that is done later. And this may complicate things to the point where you get this nested calls that are getting more and more and more complicated and more dependent on one another, to the point where it's difficult to read them. Fortunately, in Scala, we have something that can help us read this code called for yield notation, which looks like this. So what's happening here is that if we are able to keep those using those flat maps in a way that the monadic laws allow us, like maybe not allow us, but rather force us to do if you want to actually make them work, make monads work, then we are allowed to use notation that works like this. We can have this left turned like an arrow facing left that means that the result of the get team members will be returned as members here. Then we can use that members in the next line to get user data, and that the result of that will be put in users. Then we can log something, and then we can again get the priority levels from team ID, which was here from the beginning, and put those priority levels in levels. As you can see, the log method does not require does not require an arrow, because this is it doesn't return a monad. It's not. It doesn't have its own flat map. That arrow basically denotes that the flat map happens between this call and that value. And then, having members, users, and levels, we can perform some logic in the yield part. So do stuff or fail, or do other stuff or fail. And how does it work exactly? Okay, so going back to the monadic laws, we have that unit, we have the constructor, we have the flat map method that allows us to get the data out of the monads, transform it, and put it back. And we have something called the left identity. The left identity means that if we create a monad with data inside, and then we flat map it, so we call over some method, like let's call a method called f, then that should be exactly the same. The result of that flat mapping of the data should be exactly the same as if we directly called f with the value as the parameter. So those two notations, constructor of the monad dot flat map f is exactly the same, gives us the same result as f called on the value. And yeah, that's it. The right identity is like the opposite of it. So let's say we have a monad of some type of V, then we flat map that. So we take the data from inside that monad and we flat map it, but what we flat map it over is the constructor. So we just get that data and we just put it into a new monad. And that should mean that the result of all that operation should be exactly the same as the original monad, because we had a monad, we put data out of it, we put it into a new monad, but it's exactly just the same monad. Nothing was transformed, nothing different happened. So we have the same monad right now. And the third thing is called associativity. Associativity is if you ever had an algebra at college or uni, you may have come across this term as well. It means that certain operations that are in that are to be performed in some order can be performed in different order and give us the same result. So, for example, if we have a monad with some data A inside, and we flat map it, and then we have a monad with some data B inside, and we flat map it, and we take those A and B and we do stuff on both, then that's in Haskell, we could write it like this, that we have that we first perform that flat map between B and do stuff, and then the result of it is again then we perform a flat map over A and that result. So we are like going from inside out, right? If we write code this like this, MA flat map, MB flat map do stuff, then we first perform do stuff, then we have this flat map out of it, and then on top of it, and then we have flat map on top of it. But that means because operations in a monad are associative, that means that we can switch the order. If we first flat map MA with MB, and then the result of this is flat mapped on do stuff, the result will be exactly the same as what we did. So that means that we basically can drop the parentheses altogether. The order doesn't matter. Whichever happens first, whichever operation is done first, it doesn't matter. The result will be the same. So, for example, you can think of it as addition. If we have 5 plus 3 plus 8, it doesn't matter if we first add 3 plus 8 and then add 5 to it. We can do 5 plus 3 plus 8, and this is the same result. So the parentheses are not important. And thanks to that, Scala can use it. Scala compiler can use it in a way that every two flat maps can be used together. So instead of having this nesting that we have flat maps inside flat maps inside flat maps and so on, we can always have a flat map that creates a tuple and put that tuple into a monad, and then another flat map is the next one is not yet nested but outside, and what's the value inside the monad that we're flat mapping is that tuple. So we can just write it like this. We can have MA of flat map, then MB of flat map. We create a tuple from those two. And then the result, the monad with the tuple, is then flat mapped, and we get that tuple out of a monad, and we do some stuff. And since this is possible, it means that we can just write the same thing in a bit different way in this for-yield syntax, that we can have a first line that is this: we take the A out of MA monad, then we take B out of the MB monad, and we can do stuff on parameters A and B, get some result, and return that result. And for example, we can also have a log statement inside in between, because it doesn't really affect anything. The only thing, at least in Scala 2, I don't know about it right now. I think this is a bit more tolerant, but back in Scala 2, there was also this one limitation that the first line in the for loop was telling us what kind of monad we are working with. So, for example, if the first line was about an option and taking data out of option, then Scala compiler assumed that all the other lines here will also work on options. And if it was either, then all other also were either, and so on and so on. Right now, I think it's a bit more smart. And anyway, it's possible to mix monads with other monads. It's not like we always need to keep like only options with options and only iders with iders. Okay. So this kind of ends our part about error handling and like introduction to monads. I hope it wasn't too scary and you maybe got an idea how those things can be used easily. Especially, I would like to invite you to try out options and iders and tries in your code if you didn't yet. I think they are like 80% of your work can be done only with those monads. We don't really have to use anything else. But if you want it, there's also like a whole the whole concept of a effect system, which takes the idea of a monad and the idea of functional programming a step further. And this is what I would like to talk for, I don't know, maybe 30 more minutes. Any questions at this point?
Nothing on Twitch either. All good.
All right. Okay. So I have this. Let's go here. Right. Oh, I just need to move this part right of it. So, I have a small program here that basically just simulates some very simple operation on a text file. We have this little text file called users CS file. It has two users, Jonas Canwald and Hannah Canwald. They have their names here, their IDs, their emails, and their age. And what we want to do is to read data about them from that file, then deserialize them to user data, then ask for update on their age from the person who runs the program. Then we update that age and we create new text lines with that updated age and we write the data to the text file again. So I already prepared the version that is side effects versions, which means that we do it exactly at the point where we want. Where if we read data, we read the data. If we update, we update. If we write, we write. So this is like a very typical program we can basically write it in run it in the debug mode and see what's happening. Oh, sorry. Yeah, probably. That's fine. One second. Okay. So I'm reading those two lines. I'm transforming those lines into users, 0 and 1, Jonas and Hannah. Then I ask for an update, which, yes, by how much should I update the age? Let's say 5 years. Okay. If I now go here, you can see that, okay, Jonas is 37 years old, Hannah is 67 years old, but I now create an updated versions of the user data where Jonas is 42 and Hannah is 72. And then I serialize it to new lines, and then I write it to user CS file, and you can see that these two, the age of those two people are now updated. So this is all fine, and this is pretty easy to read, and it works and so on. But the thing is that if we that this all works as side effects, right? We actually have some mutable data in that file that we read in, then we update. So that means that we are asking for an update, me, the person who runs the program. We create new versions of those user data, and then we write again to the file, and it all happens like step by step. This, from the point of view of functional programming, this is not ideal, because what we would like to have is a program that really just performs operations on immutable data and never needs to actually change anything on the disk, on the files, on the internet, and so on. In practice, of course, this is not only unrealistic, but also not what we want, because if a program doesn't do anything on data, then it does nothing at all. But there is like a risk that if this program, for example, would be much more complicated and it would work on many threads, and one of those threads would write information to a file, and the other would read that file and also write some other information to the file, then we could have like an error because two different threads are working on the same data. One remedy to it that functional programming suggests is called an IO monad. And an IO monad is, well, we already talked a bit about how we can give a function as a parameter, and that function will be stored and only called when needed. For example, if we have a lazy collection, we don't need to evaluate the elements in that lazy collection eagerly. Instead, we can just keep in that the logic which will generate the elements in memory in that lazy collection, and only when we need it, we will call that logic, and that will generate our elements. So this is how effect systems in sort of how functional programming can help us as well. An effect system is a system that can give us some tools like the IO monad that will, instead of performing operations on data, will instead store what we want to do as a form of a scenario. So what happens here in case if we use an effect system, instead of a straightforward version of the program, is that we will, instead of reading data from the file, we will just put in the IO monad the call to the read method, and that call will be stored and not used yet. Only it will be used when needed. Then we say, okay, we have an IO monad with the logic inside that reads data. Let's flat map it, and when that data is read, then we will map it to users. Those lines of text will be changed into user data. And then again, let's flat map it. Let's ask for update, but only at this point. We will only when the program is run. Right now, all we do is we put inside the IO monad that, okay, at this step, we want to ask the person who runs the program for an update. We don't do that yet. And then again and again, we update the user data. We perform the serialization again to a text, and then at the end we will write those new lines to the file, but we don't do it yet. We just save that we want to do it. We want to do that that operation at some point in the future when the program is run. And what we get is an IO monad with all those steps inside. And only when the method execute is called at the end of creating the scenario, this is when all that logic, all those steps are being executed, actually. And the effect system is one that do it for us. We as programmers, we only perform this. We only propose the scenario. We say what steps there should be done, and we put them in that IO monad and give that IO monad to the effect system and say, okay, now the scenario is ready. You can execute it. Let's do it on an example. So what we will use is called cat effect 3. It's an effect system done by the type level company. And we will write it. Let's just, okay, this is our close other tabs. Let's just keep this one open for reference. And what we will write is an IO monad that will have inside all those steps. We will have this, we will read the data, deserialize it, update it, serialize again, and write to the file. We will put that logic inside the IO monad, and we will give that IO monad to the cat's effect to the cat's effect system to run it. So what we need is actually, let me take a look to my notes. Okay, what we want to do first is to get lines of text from the file. So user data file path read method is this one. It's not implemented yet, but it will be in a moment. And the read is now the IO constructor, yes, exactly like this. So what we have here inside is actually just a normal way in Java or in Scala how we can read data, read text from a file as a list of lines, but we wrap it in a constructor of the IO monad, which means that instead of performing it, we will just put it inside a monad. It will be performed later. So, and because we use the for yield notation, this means this is exactly the same as if I wrote something like read user data and then flat map something else and then flat map something else. But just for readability, I will use this arrows notation here. So we have lines of text now. What we want now is to user data from line. Yep. And then I want to ask for update. Okay, ask for update is here, and this will be also a for, where first what I want to do is to write. Yeah, cat's effect also has a methods like IO print that lets me display something on the screen. It's just for utility. I could also write a print line and wrap it into an IO. Cat's effect simply lets me use a method print that will do it for me, so it's a bit easier. And what I want is to get an answer from the person who answers, that is me. And yeah, and that will be just this read line and wrap it into an IO and then yield answer to int. Let's say, just for simplicity, that the answer will always be a number. So as you can see, that might be interesting a bit, that here we even though this is a logic, this will display a question and then it will read something from the console. But in terms of our program, this is just a value. That's because what I have here, this ask for update, is simply an IO method with some logic inside. Nothing is yet happening, like nothing is displayed, nothing is asked for. This is just some piece of code that is wrapped inside the IO monad. So, and that IO monad is a value. It's not a method. So this is perfectly okay. And when it is called, that ask for update will give me some number n. And now I will just use users, traverse. I think I should, yeah, this is all right. Traverse, update age. And update age will, for every user of the type user data, now I want to update the age of that user by n. So this will be like new age equals, yeah, user age, the original age plus n. I also print line the age changes, so we will know what's happening. And I create a copy of that user with the new age, and I return the updated user. What I want to do is to use the traverse method here. This is all in red for a moment, but it won't stop. Oh, maybe like let's, if I now stop it, because I'm still in the debug mode from the previous example. Okay, but when I run this code, all those red codes should stop being red. I use the traverse method on the users list. If I used a simple map to update, then what I would get would be a list of IO monads, which is not what I want. Instead, what I want is a one IO monad with all the users' data inside, and the traverse method is for that. And now when I have the updated data, what I now need is to new lines. I need to serialize it again. Updated map to line. And when I have those new lines, I want to write the new lines to the text file again. And the write method here is again a simple file write string that is wrapped into an IO constructor. Okay, if I and now I need to also write yield and just return nothing. Let's say -5 this time. Yeah. So what's happening now is all those lines that I wrote here just create a scenario step by step. First, I put this. I create an IO monad with a logic to read data from the file. Then I change the lines to the user data. Then I ask for the update on the age. Then I update those user data with the number I gave. Then I create new lines, so serialize it, and then I write down the data back to the back to the file. But the moment this is created, this is only an IO monad. What is happening when I run the program is that first of all, the cat's effect. I create an object of the cat's effect class IO app simple. Sorry. And that class exposes the run method, which I override. And at some point of running that IO app simple, cat's effect calls the run method, gets the IO of the type unit, because I don't put anything here. I just want this to be performed. So it takes the IO monad I created, and only then at some point later, cat's effect executes that IO monad, and only when it is executed, all those data is all those logic is done. It's like that data is read. I am asked to update the age, and the updated users are written down to the CSV file. Okay, so I asked about this program people who work on Cat's Effect, and they wanted me to tell you that actually this simple example may look a bit like there's too much to write and too much to understand in comparison to how much work it does, because of course we have this side effects version here, which is quite similar and easier to understand and easier to write, like everything is happening directly. While in case of the cat's effect version, so you can see that we just write IO everywhere, and there's a for real notation instead of directly doing things and so on. So I agree that this might look a bit too complicated for the effect it does. But this is only to show you how you can work with effect systems, and how that code created this way will look like. What is a real advantage of an effect system becomes more apparent when the code becomes more complicated, because if you write it in this way, like this, like here, it help you make more checks, make your code safer. It can like save you from certain types of errors in the compilation, instead of having to see how they happen in runtime and debugging and fixing those errors only there. So this is just for you if you want, you can download this example from a GitHub repository, play with it, make it more complicated, maybe find another one that is already more complicated and does something practical already. And then you can decide for yourself if this is coding style that seems to you to be interesting and practical or not. Okay. Are there any questions?
All good on Twitch as well.
Okay. Yeah, so if no questions, then I just wanted to come back for a moment to a bit more high-level theory. Yeah, basically, my own idea, my own opinion, is that we shouldn't do things in a more complicated way than absolutely necessary. There is this kind of a trend in programming where we like complexity, like writing complex code seem to us as something that is that is the way we should do things. Like things shouldn't be simple because otherwise we wouldn't have this job, right? Like we do complicated stuff, so it is somehow okay if we do it in a complicated way. One of the a side effects of this is that every time we see in our code bases code that looks similar to something else, in IntelliJ we even have a feature for that will show us that this code in this file looks similar to another code in a different file. Those five lines looks like those 5 lines. And maybe you should then look how to make them abstract them away together and put them somewhere together. And those two places which are similar should really be just calls to one method that is more abstract and more complicated. But this way our code will be better. And yes, sometimes it really is. But in many other situations, it would really pay off if code that is not exactly the same would stay not exactly the same. Like if I have code that is 5 lines long and is kinda similar, but only kinda similar to other 5 lines, maybe it's okay if they stay like this, because if they just do their work and if something works, maybe it doesn't. We shouldn't change it. So for me, if we have these two paradigms, keep it simple, silly, and don't repeat yourself. My bet would be please keep it simple instead of trying to make it so that no code is ever repeated. And same goes for some very complicated concepts and abstractions. And as my friend Nicolas Rinaldo once tweeted, so okay, a monad is probably a term simple enough that it can be just called a monad, and that explains a lot already. But sometimes people call certain operations called folding. They say that they are catamorphisms, and that's really just something that people use to feel themselves to be smarter than others. So I would rather not overuse complex terms, not overused abstractions, just keep things simple. And yeah, because we all have our deadlines, we all have our we would like to finish our work at some point at the day and have a free evening. So don't overdo it. Don't try to be too smart. Just do your code, make your code good quality, but when it is already good quality, just say, okay, that's enough. That's good enough. I'm happy with it. And yeah, so I would propose to just keep things, just strive for readability and simplicity, and that should be that way our code can be beautiful and easy to read, not only by us but also by our team, and that's what counts, right? The unit that produces code, that works on code, is a team. It's not not a single programmer. So it's better if code is kept in a way that every one of us, every member of the team is able to work on it. On like another note, I'm in my free time, I train martial arts, both Aikido and kickboxing. And they are both like on a separate ends of a spectrum. Aikido is very complicated, very beautiful. It's full of complex techniques, wrist locks, throws. We try to control the momentum of the other person, try to perform the technique in a way that is very gracious and looks awesome from the outside, and also from our perspective. But it's like not always practical. It's kind of much more like kickboxing. It's much more practical than that. In kickboxing, you just learn to punch people, kick people, and most of the time this is enough. And only when I think, okay, I already learned how to do all those kicks and punches, and I'm already bored, and I would like to do something more, then I go to Aikido and then try to do something more interesting and complex. But that's because I already know the basics, and so I have those foundations ready, and that gives me some kind of a sureness that if I can, I can just do everything. Like I can uh, that I can save myself, I can protect myself by using something simple, and I just do Aikido for fun. So, like moving this to programming, I would say that, let's say, 80% of the time, what you need are really just simple things. Knowing how to work with collections, knowing how to pass functions, transform them, and return them, knowing a bit about recursion and enums and algebraic data types, and maybe just a bit about error handling with monads. And that should cover most of your situations in programming. All more complex functional programming techniques are fun, and sometimes they are practical, and they could help you, but only when you are pretty sure that you did what you can with those simple things, and this is on top of it. This is something you use because you think it can. You already like tried everything simpler. It didn't work, so now you go and try something more complex. Don't try to use Aikido when kickboxing is enough. And yes, I would like to invite you to go to the JetBrains Academy plugin page, look through the courses there. This one, the lectures I just gave are based on the functional programming in Scala course that is also available in the interactive version in the JetBrains Academy. There are also other courses. Maybe some of them will catch your attention. And thank you. You can also read more about the IntelliJ Scala plugin on our blog. You can find us on Twitter and since recently also on Blue Sky. We have a Discord server, and also you can look for me on that Discord server, on Twitter, and on Blue Sky. And here's also the link to the GitHub repository with all the examples I showed you during this course. Thank you very much.
Thank you for the awesome presentation and the three-part course. Really appreciate it. Any last minute questions, everyone? Great. Well, I'll work on publishing the recordings over the next 1 or 2 weeks. And then once they're done, I'll send an announcement to everyone who's subscribed to our meetup group and Luma and share it on Twitter and everywhere so everyone's aware it's done. And once again, I can't thank you enough, Maciej, for doing this talk. Please keep in touch. Open invitation if you ever want to come back and do any presentation at our group in person or online. And hope and anyone who was on call is based in San Francisco. Hope to see you on Tuesday. Other than that, I guess I'll let everyone go and enjoy their Saturday wherever you are. Yeah.
Yes. Thank you very much. It was a pleasure to be here.
No, thank you so much again, Deb. Please, everyone, keep in touch. Thanks so much.
Goodbye.
Bye. Bye now.